Hello everyone. Today we will see how we can write RSA program in Python, and not much libraries are used, like pre-built libraries are used. I am just using random and math library, so everything like the logic, every logic will be written by ourselves, so you can understand things. So many of the students like me do face quite difficulty understanding the RSA and quite pay a tough time understanding it. So that's the reason I am making this video, one of the reason I'm making this video. And the another reason is that people do understand the theory behind the RSA and are able to calculate the sums for the examination purpose. But when it comes to code, most of people uh, don't able to understand the code, or don't able to understand the logic to indulge into the code. And to be very honest, I was also one of them until last night, because till that time even I did not practice, and today I am just practicing just because today is my information security examination. So yeah, that's the life of engineer, you can assume that, right? So fine, so let us quickly dive deep into this. So firstly, as RSA is concerned, of course, the first step of ours is to calculate the two very large prime numbers, right? So as of now, I am guessing that you might be able to hear the sound of my fan. So I am not that computationally rich as of now, as of this moment, right? So I am just calculating the prime numbers from 1 to 100, and then finally I am choosing the any of the two prime numbers from the list I have made over here, as you can see, right? So I am just choosing the prime numbers from 1 to 100, and I am just keeping it into P and Q, right? So that's about this function, and here is how we are basically generating the P and Q. Most of the people do write the code that way, that we have to manually insert the P and Q, right? So I am a very lazy person, to be very honest, and I don't like to calculate anything. So I just wrote code for the prime numbers, and then finally everything was automated. You just have to run the program and see the output. That's it, right? So that's that. So till now here we are just calculating the P and Q. Let me just quickly first run the program and show you how it is working. So here there will be random P and Q which will be generated and which will be referenced over here. Then finally n will be calculated, and let me show you what is n. So n is nothing but it is simple multiplication of P and Q, nothing rocket science in that, right guys? Then finally we have Euler's quotient, and that is nothing but P minus 1 into Q minus 1. I won't be going into the theoretical part. If you want to see, there are numerous videos out there on YouTube which are explaining RSA very better than me, and to be very honest, even I am also one of them who have learned from the YouTube, right? And another great website is Geeks for Geeks. Geeks for Geeks. You can always go there, and you can watch, like you can read out the article for the same. So let's move further. Then finally there is calculation or generation of E, right? So for what is E? So E is our public key, right? So for public key, these are the conditions which you have to keep in mind. So the first condition which says that the GCD of your E and Euler's quotient should be 1. So here I have done nothing but I have done that thing. Here you can see I have kept an if condition wherein I am just calculating the GCD of I and phi, and here I am running the for loop from 2 to 5. So there was the second condition also which you have to keep in mind, which is your E should be in between 1 and 5, right? So I just did that thing. Here I have taken 2 because I didn't want to take 1, because uh, it might result into falsy cases. So for like being on a safer side, I am just starting my range from 2 to 5, right? So from 2 to 5, any of the I and the phi's GCD where it is 1, it will be basically inserting it into the E, which is our public key, right? And one of the fun part, what I just noticed and what I just saw, I also wanted to give that fun to each and every one of you who are watching this. So I just wanted to show you all of the possible public key combinations which can be made. So here I am just reran the program, and I have just printed all of the possible values which can be calculated from this Euler's quotient, right? So these are all the possible value, all the possible what you can say public key values what you can take for your calculation, right? So that's the beauty of mathematics. That's all what I would say, right? So here's the thing, and any of the value you can select from this. So let me just not stretch much in this part, and here as you can see I am just randomly choosing any of the one value from this of the public keys, right? So that's the thing. Other like after this thing, let me just quickly save the program, just clear up the screen and rerun the program, so just to see that everything is working fine and nothing is broken. So at the end also I have to provide the code to you, and it is already 4 a.m. and I also have to sleep and give exam tomorrow, so that's thing. But anyways, let us focus. Then we are generating our D. So D is nothing but our public key. So how we will be generating our public key? So there is this constraint which we have to keep in mind, that our ed mod phi should be 1, right? So here is the same condition which I have written as of now, that our like our D and E multiplication of our E and D and mod with our phi should be 1. So that's the thing which I have kept which I have taken care and basically calculated my D. So here one more fun part is that I always, like our teacher always used to say us that for every public key there exists only one and only one unique private key. So I always used to question that if you are able to generate this many public keys, then there might be some sort of the collision between the things, and there might exist some of the other private keys, right? So I did like as I was doing this practical, I did this thing, and just to show you that thing also, here I'm just not breaking up the things, and just to show you that everything is working fine. I am like, how did I code? So I am if my this condition is satisfied, that means I have got my private key, right? That's the thing, and that was the reason I was, for optimizing, I was just breaking up the code, like breaking my loop at here, right? But as of now I also wanted to show you that how many possible private key combinations can be there. So any guesses, guys? You can pause the video and comment down below that what will be the number of the private keys generated for this public key. So you can pause up the video and you can comment down below. But as of now I'll be calculating this thing, and our teachers were right, guys. So only one and only one private key is generated for a unique public key, right? So that's the thing, and that's the beauty of mathematics again, I would say. Let me just quickly comment up the code, and that is the reason why I am not using any sort of the D possible list over here, right? So here I also written this comment that each and every public key has only one unique private key, right? That's the thing. Other than that, we are generating D over here this way. I guess it is pretty clear from the condition I have written over here and the if statement I have written over here, right? Then finally we also have to encrypt the message. So there is also condition for the message here. Here I also written that condition that our message should be less than n calculated. So n was nothing but n into p, sorry, p into q. So that was our n, and our message should be less than n. So that's the thing, and for keeping that thing in mind, I am randomly choosing any of the n, which is basically any of the message from 1 to n. So here you can see the level of the laziness of a person, and I think I am the extremist. I am the supremacist of the lazy city, I would say. I don't think any sort of the word like lazy city exists, but bear with me as of now. So here I am just getting a random message in our range. then finally we are basically encrypting that message, and for the encrypt I have done nothing but I am just powering. So our formula is message to the power of e mod of n. So let me just quickly write it so that you guys are not confused. So what all I have done is message to the power. Where the hell did power go? Oh my god. Yes, here it is. So message to the power of e, then basically to this thing we are doing mod of n. So here this is the thing, this is the like the statement which is written over here, POW function, which is inbuilt function, and like this statement is the same thing as this statement. So that's the thing, guys, right? And here basically I am returning the encrypted text. Basically C is referenced as the ciphertext, so I have just taken C as the name of my variable, like temporary variable, I would say local variable, right? Then finally I am just storing this encrypted message in my e_mst variable. Then finally I am printing that message, and then for decryption we encrypted the message with our public key, so we'll be decrypting our message with the same private key for the same public key, right? So here I have taken my private key, and here the same thing, the formula is very similar to the formula of for the encryption. Here just the change would be in the D. Instead of powering to the E, we will be powering to the D, and then finally the mod of mod of it to with the mod of n will be taken, and then finally here it shouldn't be C, it should be plain message. Let's skip it, P for our temporary variable. So you would have guessed it why here the variable name was C, just because it is the supremacy of the programmer of copying and pasting the thing. So sometimes it may happens, but it's all fine, it's all part of life. We have to move on with such things, just just correct it and move on, that's it, or else we would be blaming ourselves for the life, I would say, forever for the life. Okay guys, so that's the thing, and then finally I have just decrypted the message, and here you would be able to see that message. Let me just quickly save the things, and let me show you. And this goes without saying that every time you will be running the program, the random P and Q will be taken, and the same way the randomization of everything is taken care and kept in mind. So everything is randomized, and every time a new thing, like a new P and Q will be generated, and based on that E and D will be generated, and the same based on that the message would be generated, right? So that's the thing, guys. If you liked what you saw, and if there are any sort of the suggestions wherein I can improve my teaching skills, so let me know. Many of people are telling me that your teaching skills are good, I would say. Many of the people have seen me, so let me know if they are really good. I would say ignore my friends, because they would never say me if anything is good. So that those are the friends, and we can not do anything. I think I have gone mad just because the time is 4:30 a.m. and I think I should sleep as of now. And like if there are any sort of doubts, please do post down in the comment section, and let me know if there are any sort of the suggestions for the same, and if there are any sort of the projects which you want me to do, let me know. If I would be free, I would be definitely doing that. Thanks a lot, guys. Thanks a lot for watching. Bye bye, good night, have a great day ahead.